Alright, this is lesson 37 for 7th grade, and today we're talking area of triangles and a little bit more about area of rectangles. These are both very important topics. We've seen area of rectangles before. We may have briefly seen area of triangles last year. It's going to be a pretty big deal from here on out to understand how these two relate and how to calculate them. Alright. First thing we need to kind of go over is the parts of a triangle, and especially with our formula for triangle area, we're going to need to know these parts. So, first of all, we have a triangle, and it has a base, and it has a height or an altitude. Now, the important thing to know here is that the height or the altitude and the base always make a 90-degree angle with each other, and it might say that in here. So the base of one of the sides is one of the sides. The height is the perpendicular distance between the base and the opposite vertex of the triangle. Okay? We're going to show you a bunch of different ways that those two can relate. But what we need to make sure is that the height is perpendicular to the base. Okay? And it has to go to the opposite vertex, in this case, this point right here, from the base. Alright. So it says here, if one of the angles in a triangle is 90 degrees, one of our sides may be the height of our triangle as seen below. So here's a few different scenarios we're going to have. This is one right triangle rotated in 3 positions. So here we have a base. Typically what we like to do is think of the base as the thing that would be on the floor. I know these are 2-dimensional, but on the screen, the base would be at the bottom of our page. So that's what we would like to think the base as. It's not always going to work out that way, but that's okay, because triangles can always be rotated. So base is here. Height makes a 90-degree angle with the base and goes to this point. So height, base. Here, we would call this the base, and this height makes a 90-degree angle with our base. Goes to the opposite vertex there. Now this one, if this is our base, if we're going to call this the base, this right here would have to be our height. It makes a 90-degree angle with the base and goes to the opposite vertex. So basically, drop straight down from the vertex, it makes a 90-degree angle with the base. Okay? That would be if we considered our base on the ground. We could technically, since it's just this triangle is actually the same, if we took out this line here, we could still call this base and height if we wanted to. If we recognize that that's a right angle, that would be okay. But if we're keeping it, we might see some situations where we have a triangle like this, where this is not a 90-degree angle, this is not 90, this is not 90, so you can't do that. So we're going to drop it down here, make a 90-degree angle, that's height, and then this is our base. Okay? So there's going to be some scenarios where there's not always going to be a 90-degree angle. We're going to have to make that happen to find our height. So that's the biggest part, is being able to find your base and your height. If we do not have a right triangle, one of our sides will not be the height. And that would be what I was just talking about. So this is an obtuse triangle rotated to 3 different positions. Let's say this is our base here. We can call this the height. Still makes a 90-degree angle with the base, even though this doesn't touch the base. But this would be our height here, 90 degrees, up to the other vertex, and lines up with the base. Here would be like the one I drew just previously. Height would be here. We've got a 90-degree angle with our base. And the second one's kind of like this one, where this is our base, and then this drops down to make a 90-degree angle with that base, had we extended the line. So, identifying base and height is very important, and I'll show us why in a second. Actually, I'll show you right now. Because the area of a triangle, this is the formula, 1/2 base times height, or base times height divided by 2. So what is the difference between these formulas and why do they both work? Alright. The difference here is that we're taking half of the quantity we get when we multiply B and H together. Or we could do half times B times height. So everything's kind of being multiplied here. Basically, at some point here, we're going to have to take a half of something, and I'll show you that in a second. This one, we multiply base and height, and then we divide by 2. So multiplying by a half and dividing by 2 are the same thing. Now, one other thing I'll show you real quick is why these formulas work and why they are the way they are. We know that for a rectangle, area equals length times width in a rectangle. Well, what if I call this base and this height? Then area of a rectangle would be base times height. Okay, so area of a rectangle there, if I call that side base and that side height, we get base times height. Well, if I do this, and I make a triangle in there, how much is one of these triangles compared to our rectangle? Well, this triangle is half of this rectangle, so that's why we say area of triangle equals 1/2 base times height. And that's where the formula comes from, which is pretty cool. Alright. So, let's use what we know and find the area of this triangle. It says use area equals base times height over 2. Doesn't matter to me, we could use either formula. Area also equals 1/2 base times height. Well, we have to figure out what our base and height are first. Let's go ahead and call 5 our base. That's the one on the floor here. And that will be useful because the thing making a 90-degree angle with our base is 4. So let's call this height. So our base and our height, 4 and 5. If we do it this way, we'll get 1/2 times 5 centimeters times 4. Okay? We can do a bunch of different things with this. I could take half of 5 first and then multiply it by 4. I could take half of 4 first and then multiply it by 5. I could multiply these two together first and then take half of that. Let's go ahead and do that. So really we have 5 times 4 is 20. So I want 1/2 times 20, and we know that is 10. And we are in area centimeters squared. Alright? If we would have done it like this, we would have done base times height. 5 times 4 was 20, divided by 2, we still would have got 10. Other ways we could have done it, 1/2 of 4 is 2, 2 times 5 is 10. Alright? Lots of different ways we could go about that. So that's why it's important to identify your base and your height. Remember, they are always going to make a 90-degree angle with each other. Alright, next one here. Check my time quick. Still doing good. It says high in a wall near the slanted ceiling was a triangular window with the dimensions shown. What is the area of the window? Okay. So we're going to use area, 1/2 base times height. Right triangles are easy because the right angle, that's exactly what we want. We want our base and our height to make a 90-degree angle with each other. So base here is 6 and height is 3, and we are in feet. So really we have 1/2 area equals 1/2 times 6 feet times 3 feet for height. So we could do 6 times 3 first and get 18, and then take half of that, which would be 9. We could do half of 6 is 3, and then 3 times 3 is 9. Either way, we're getting 9. So 9 feet squared. And we're multiplying 2 units of feet. That's where we get the squared from, just like we did up here, even though I didn't really show that. but we are in area, so we should be in feet squared. Okay? And before I move on to this one, we will be seeing other triangles tomorrow as well, where we'll have to identify base and height in different situations. Alright, the last thing that we need to talk about is this problem right here. We've already done rectangle area, but this is kind of a new one. This is a floor plan of a bedroom. The dimensions are in feet. All angles are right angles. What is the area of the room? So we don't have just a rectangle. We have kind of an irregular shape here. So there are two main ways to solve this problem. There are actually many ways to do it, but two main concepts or ways to do this. I'll show you one way. What we can do is break this into two rectangles. So maybe I take that and extend it right there. And then we have this rectangle right here. And then I have that little one off to the side right here. Okay. Now the only thing that we need to do is figure out this missing piece right here. Okay. So we know that this side is 12 and this side is 10. So area of our rectangle here equals length times width, which is 12 times 10, which equals 120 feet squared. Okay? So area of that large rectangle is 120 feet squared. Now, how do we figure out how long this side is? Well, I know that this is 13 feet, the whole thing. But I know that this is 10, because this is 10, this has to be 10. And if this whole thing is 13, this has to be 3. So now we have a 3 by 7. So this blue one should be length times width, which is, let's just do 7 times 3, 21 feet squared. And what we would do with those is we would add them together to get the overall area. So total would be 120 plus 21, we would get 141 squared, I believe. Let's check that answer and make sure we're right there. And then I'll check my time, see if we can show you that other way to do it. But I think we ended up okay. Let's see here. Oops. Sorry about this. Where is it? Oh, there it is. Yes, 141 feet squared. Alright, we've got about a minute or so, and I'll show you the other main way to do this one real quick. So here, find two separate areas and add them together to get the total. Here's the other way we could have done this. If we extend this out, and we would say this is 13, so we have a 13 by 12, we would do length times width, you get 13 times 12, and what we could do then is figure out what this would be. And this is not part of all this area, so what we would do is subtract this, which would be what, 3 times 12 minus 7, so this is 7 and this is 12, this has to be 5. So what we could do is take our large area and subtract out 3 times 5, because that's not part of it. I like doing it this way because it seems to be a little shorter and less work, but it's up to you. Either way, we should come up with the same answer. Alright, we will cover more of this tomorrow.